In the module today that we're going to be addressing, we're going to be looking at stress testing. And stress testing is a part of all of the different aspects of performance testing that we've already been talking about. In previous module, we looked at load testing, and we also talked about how important it was to have a good set of requirements and to set up the environment. But today our objective will be focusing on how do we do stress testing, and in particular, as most of the topics in this class, how do we do it in a very systematic way. So what we are trying to achieve when we talk about doing stress testing is to verify the behavior of the system meets its requirements when its resources are saturated and pushed beyond their limits. So this is a little bit of a difference from general performance testing. Now we're attempting to push the system to its limits. And our goal here is to attempt to find the stress points and to ensure that the system performs as specified. What is that? Well, again, having to go back to the actual performance requirements. So the performance requirements need to address what the system should do when it is indeed under stress. Now, there are a lot of analogies that I'd like to start off with. Software engineers are not the only ones who worry about stress testing. The first one we might talk about, doctors. Maybe some of you, as a part of a physical exam, went through a stress test with a physician, and that might be part of, for example, a sports physical. Automobile manufacturers may begin thinking about doing stress tests on a car. And if you ponder that, what might be a stress test on a car? Well, it could be a speed test, how fast, trying to get the car to accelerate from 0 to 60. Or maybe a stress test could be going, from 75 miles per hour, braking down to 0. Or maybe a stress test could be trying to start the car when the temperatures are 20 below 0, or trying to drive the car with very heavy loads. Lots and lots of different forms of stress tests might be performed. And since we're in the engineering school, we can think about other engineers, and in particular maybe civil engineers, and you might think about when you're building a bridge, what would be a stress test of a bridge, and do they need to do forms of stress testing? So in addition to thinking about software, we'll think a little bit about these analogies and how do professionals, how do testers in each of these areas address the system testing. Well, we're going to try to work our way through this with 4 steps. The very first step that we're going to look at in any sort of product is to identify the stress points. Now, although system testing and the kinds of testing we normally think about doing with performance, those are normally viewed as black box types of tests, basically defining the requirements without necessarily having to see code or understand what's under the hood, so to speak. When we're doing stress testing, though, it is important for us to work with developers, work with the architects to try to identify what we might believe are the stress points. Because ultimately, we're looking at where the system potentially could fail. So when we go back and we think about some of our analogies here, when the doctor is trying to do a stress test, what resource are they really trying to stress? What are they stressing? Well, hopefully it's pretty obvious, right? The physician is attempting to stress the cardiovascular system, the heart. When you talk about an automobile stress test, well, it might depend on, which kind of tests we're doing. If we're trying to be going from 75 to 0, that can obviously is a stress test of the braking, maybe a stress test of the suspension. We can think about crash tests, that could be a form of a stress test as well. And in the same way, when we think about a bridge stress test, we really want to think about the architecture of the bridge. Where are the stress points? Where do we think that this bridge potentially could fail? Now, taking this back into software, again, we're trying to think about where are the potential bottlenecks. And in software, potential stress points could include things like the CPU. We're trying to stress the CPU to get it to up to 99.9% utilization and see how that impacts performance. We might be stressing memory, we might be stressing different buffers or other resources in the system. So the first step is to think and have a strategy. What are the stress points? And again, that's something that you typically have to work with developers and architects. Once that's in place, kind of the next activity is to develop the strategy to stress the system. What are you going to do? Another example, I didn't have as a previous one, but maybe think about cell phones, mobile applications, and maybe a provider. If they were trying to do a stress test of a cell phone system, what might that look like? Well, I'll give you an example. Maybe you've got Verizon in Tempe, Arizona, and they want to do some sort of a stress test of a new release. Well, maybe they can go to ASU Sun Devil Stadium. They could ask for people to go into the stadium. They could give them a mobile phone. They could put up on the scoreboard a countdown, 5, 4, 3, 2, 1, and instruct everybody, maybe 60,000 people, to simultaneously make a phone call. That's a strategy, okay? That is a strategy for trying to stress the system. Is it a practical strategy? Of course not. And so when we typically do stress testing, it's often going to require us to have tools to be able to try to generate the load on the system. So going back to our example, the human stress test, what might be the strategy to test your heart? Well, probably the physician, in most cases, might be putting you on a treadmill or something like that, at which point, he's going to kind of crank up the RPMs a little bit, have you walk or jog on that treadmill, and that would be the strategy for basically trying to introduce stress. The automobile stress test, again, this may be the case. You've only got a single device where you might be going in and attempting to probably do some crash tests or do some accelerating deceleration. Okay, so you might physically be doing some of this. The bridge stress test is a little bit more interesting. What would be their strategy for doing this? Do you think a civil engineer is going to build an entire bridge, maybe across a canyon or something, and then as part of a stress test ask for a volunteer to walk across it, and then maybe ask for a group of people to walk across it, maybe ask for someone to drive a small car across it, maybe a bigger car? I don't think so. Okay, so as we begin thinking about some aspects of engineering and stress testing, a lot of this is probably going to need to be done on prototypes and models, and certainly the case will be true in software. So back to the software, developing this strategy, in some cases, maybe still in most cases, we may end up doing the equivalent of building the bridge and trying to drive very heavy vehicles across it, but typically doing that with some sort of tools, okay? So creating, if we were doing that phone system, we would have some sort of a simulator to generate calls, or a typical client-server application, the ability to have lots of clients or ways of being able to access the system. So many strategies for trying to do it. Third step, verify, the key word there is verify, the intended stress is actually generated. And so you've identified a stress point, you've got a strategy for trying to stress the system, but now you have to make sure that you truly are stressing the system. And in some cases, you may think you're putting a lot of load onto the system, you're stressing it, but the system may be better than you think. Maybe going back to the stress test, the doctor might put you on the treadmill. You might be on there for 15 minutes. The doctor comes back, checks your heart rate, other indicators, and sees, hey, your heart is really not stressed. Maybe asks a few questions and identifies that you run marathons, at which point the doctor says, oh, I get it. And all of a sudden, the incline on the treadmill goes up and the RPMs go up, because as part of the stress test, we really do need to increase the heartbeat. We have to increase the stress. Same sort of a thing for the automobile, certainly the same sort of thing for bridges, and certainly the same sort of thing for software and software systems. we may think that we are stressing the CPU. We may think that we are stressing memory, but we need to get some data. We need to look at it and see that we really do create the stress that we're hoping so that we can actually verify the performance. The system performance might be better than we planned, or there might be other things going on in the system where the load is being diverted. And then last, but also important and also very difficult, we need to observe behavior. Verify stress-related requirements are met, that the system is doing what it is supposed to be doing under that load. Going back to that cell phone example, filling up the stadium, everybody makes a phone call, 5, 4, 3, 2, 1. If suddenly everything goes black, okay, all the phones crash, well, observing the behavior was very easy. System failed. But what if all the calls went through? Now we have to verify all the requirements are met. All the billing records were created. Everything was done appropriately. Back to our analogies, the human stress test. You're going through the stress test, and 10 minutes into the stress test, the patient has a heart attack, falls over, and dies. Well, the doctor's job is pretty easy. Patient failed the stress test. But what if they walk? What if they get off the machine? Did they pass? Well, not necessarily. Typically, the physician then is going to say, okay, now I've got a lot of data. Make an appointment for next week. Give me some time to analyze everything, and we'll talk about the results. And so typically in each of these cases, when we're trying to go in and do stress testing, we have to plan for how we're going to observe behavior. Because if the system doesn't crash, it's going to take all that information that we have created and thrown at the system, digest it, throw it back, and then it's our job to basically observe the behavior. So stress testing is hard. Often it's viewed as an ad hoc activity, but as everything we've been doing in this class, we need to look at it as being a little bit more rigorous. So as a quick summary, stress testing is part of the performance testing that we've been looking at. It's a form of load testing, but it's where we're going to push the system to the limit and observe that the results, and in particular the performance requirements, are being met under various stress conditions. Thank you.